let's get started. So
did you share it to someone?
yeah, I shared. Oh, it doesn't work. Okay. So recently, Gemini 1.5 demonstrated some planning ability in their technical report, and the next generation of language models are already demonstrating capabilities in planning. We're not sure exactly if it is planning or not. This is still a debate. But soon, results on planning benchmark will be a standard feature in every new release of LLM. And that is why it is more than important right now to revisit and refine the suite of benchmarks that are around for planning in natural languages. And hence, I'll be covering a few benchmarks, starting with one of the most famous and probably one of the first natural language planning benchmarks, which is PlanBench. This was a paper in Europe's 2023. It has two domains, Bloxwell and logistics. And also, they have an obfuscated version of those domains. And they cover 8 tasks, first of which is plan generation. The second is cost optimal planning. That is, can a LLM generate a cost optimal plan? Third is plan verification, which is essentially asking if the LLM can determine if the provided plan would, when executed, would reach the goal or not. Fourth is reasoning about plan execution. That is, can an LLM understand what would happen after a sequence of action is executed? Fifth is robustness to a goal reformulation. That is, once a goal is represented in a different format, is rephrased, does LLM still, find the plan? Is it robust to the rephrasing of the goal? The sixth task that they present is the ability to reuse the plans. That is, once the LLM is given a plan for some other goal, can they reuse it to and generate a plan for the current goal? Seventh is replanning, which is similar to the previous one. But in this sense, in this case, the change is unexpected. And then the plan generalization essentially checks if the LLM can take specific plans and extract procedural patterns. So it is essentially the generalized planning problem where you are asking LLM to provide you a policy instead of a plan. So these are very, difficult tasks. And I really doubt, we will see much progress on this benchmark anytime soon. But the idea is that there are different, benchmarks, which I'll cover. And there are also different ways of asking language model these, reasoning tasks, which are closer to planning or auxiliary tasks around planning. The second one is AutoPlanBench. The PlanBench data set was actually hand-coded, and hence it was limited to 2 domains. AutoPlanBench provides an approach using large language model to generate these benchmark automatically, and hence they were able to scale to 12 domains, but they only have this one task, which is plan generation. The next up is the ACL paper, which provides textual reasoning about action and change data set. They have only a single domain, that is blocks world. But the way they, the way they phrase the blocks world questions and the states and the actions is quite different from what we have seen in the domains that were generated from the PDDLs. And here they have 4 tasks. First one is projection, where you ask the language model that given an initial state and an applicable sequence of action, decide whether a proposition, which is the query here, would hold after the execution of the action or not. For example, if we are given the state and then the action is that Jane moves the green block from table to the red block, and the query is the blue block is on top of red block or not. So the answer would be false because Jane just moved green block on top of the red block. The second task here is executability, that given an initial state S and the sequence of n actions, decide whether they can be executed consecutively in the state. The third task again here is plan verification, that given a state and the goal, does this action achieve the goal or not? And finally, the fourth task here is goal recognition, which is given a state and a plan, verify if the mentioned condition, that is the goal, is mentioned query is a goal or not. So we are given that Jane moves the blue block from the magenta block onto the table. Would blue block on top of magenta block can be a goal for this action or not? So this is a natural language, domain provided by he et al. In ACL 2023. And the beauty of this benchmark is that they have all the examples are binary question answering, yes, no. So they are very easy to evaluate. Whereas plan generation and all the previous tasks are a little difficult to evaluate. The fourth benchmark that I'm going to present is the LLM+P. This was a he et al. paper. Oh no, so this is I think Zhang et al. I think I messed up the names. Okay. The citation is incorrect, but they have 7 domains and they have 2 tasks. First one is plan generation, where they directly ask the language model to generate a plan given the state and the goal. And the second task that they focus on and they show that, this is the better approach is the translation of the natural language to PDDL, where they ask the language model to first convert the provided natural language domain to PDDL representation, and then they use a planner to generate the plan. Yet, regardless of that, we have this data set which we can leverage to evaluate, planning abilities of large language model. The next up is Action Reasoning Bench. This is a recent ICLR 2025 paper. Again, this is built from PDDL, and there are 8 domains here from IPC, and there are 6 tasks. The tasks include fluent tracking. Can the language model track how a fluent would change after performing certain action? State tracking. The state tracking is an extension of fluent tracking in this case, where state can be a complete state is actually a complete set of fluents. So it's a superset of fluent tracking. The fourth one is action executability, where they ask if they are given an initial state and a sequence of action, can a language model identify which of the actions in the sequence would not be able to we will not be able to execute, or which would be an invalid action in the sequence? Where would a planner fail to execution engine fail to execute the plan? The next up is effect of actions, where they ask if if a certain proposition would again hold or not after performing an action. And this is a novel task that they propose, which is numerical RAC, which is, for example, which is asking about the number of applicable actions or number of states that number of fluents that would change and things like that. This is something novel which the other benchmarks did not have. And finally, they have composite question, which is a combination of the previous task. And last up is the benchmark from us, which is a AAAI 2025 paper, ACPBench, action change and reasoning about action change and planning. We have 13 domains. Some of them are IPC and some are novel domains. And we have 7 tasks here. First one is action applicability, whether actions are applicable in a state or not. Second one is progression. Check what would happen once an action is applied, what would be the next state. Or what would be possible in the next state. The third one is atom reachability, whether an atom can be reached from the given initial state and in this domain or not. The fourth one is the validation, where we give a sequence of action and ask if this can be if if this action sequence is applicable and achieves a goal or not. The fourth one is action reachability, which is again checking if a reachable state, if a state is reachable where action can be applied given the initial state. And all of these are important, especially in case of in the AI agent atmosphere, because some of the tasks that are given to AI agents are instructions. Say if I want to book a flight. Now, if I want to book a flight from say X location to, if I want to book a direct flight from X to Y, if would that action be even be possible or not? So action reachability is kind of important in terms of agents. So to reduce the cost of the agent, it is important to figure out beforehand if the action is not even possible. Justification, which checks whether the action is needed or not. Given a plan, check if the plan is justified or not. That is, if there is an unneeded action, unnecessary action in the plan. Then the last one is landmark, which checks whether a fact must become true along every path, every plan or not. So we have more benchmarks that are, natural language planning benchmarks that are travel planner and natural plan, and also some benchmarks that are specifically focused on conversion from natural language to PDDL translations, as well as, we have agent-specific benchmarks. And all of these are really great set of benchmarks to be evaluated. But I want to, highlight one point here, that arguably the key factor that drove the reasoning abilities of LLM is the availability of diverse reasoning benchmarks. There were a lot of reasoning benchmarks on different, set of questions and tasks, and they all followed a single pipeline of execution. They were easy to execute and they had standardized evaluation. And the pipeline that they followed was essentially all of these data sets were uploaded to Hugging Face, and they had this tool called LM Eval Harness, which was able to download the data set, and you can modify the prompts that are you can use for the for your own fine-tuned model. So if instruction fine-tuned model are fine-tuned for a particular instruction, and for every language model, you might require a different set of instructions in a different format to query that example. So all of those, that was possible because LM Eval Harness, and there are some other more tools like that, which allow you to easily modify the prompt and easily, change the language model that is being evaluated. But obviously, there have been a lot of criticisms across these, benchmarks as well. We have seen that some have criticized their reliability, robustness, generalizability, and some have questioned if they are these benchmarks are really evaluating reasoning or they are just reciting. But putting all of this aside, there is something positive to be taken from these benchmarks, and to me, that is how the community, utilized the tools that became available, and they standardized their evaluation. To give a insight of why I'm bringing this up is this table here. Look at the PlanBench data set. They have a different prompt, and this the out-of-box code on GitHub supports only OpenAI and Bloom model. AutoPlanBench only supports OpenAI, and they have a different prompt here, which is input and then a model with semicolons. TRAC, which was ACL paper, they had a different set of language models, T5 Roberta, OpenAI. And they don't have any prompt, but they had a different way of evaluating the examples, in the sense they concatenated the state and the action with the space, tokenized it, and then they added those tokens a tensor to the tokenized version of tokenized representation of the query, which is quite different from what we did, right? And then LLM+P, the code only supports OpenAI, and then there's a different way of representing their prompts, and all of these prompts are hard-coded. Similarly, for Action Reasoning Bench, they were a little better. They have their code supports all the models that are available on Hugging Face. But their prompts are limited to domain description, initial condition, and query. This is the standard format that they follow. For example, let me go back and show this here. Right, the domain, they use this uppercase domain description within parentheses to indicate that this is the domain of the problem, and then this is the initial state or initial condition, and then the actual query. In ACPBench, we followed a different format as well, which is question, thoughts, and then the final answer, because we were evaluating chain of thought reasoning. But we did spend a lot of effort to make it available and standardize it along with other reasoning benchmarks. And so we can support any of the LLMs that are available on Hugging Face, OpenAI, VLLMs, etc. And I would just like to demonstrate that. But before that, if there are any questions I can take, and then I'll switch the machines and I'll demonstrate how we support it. And I would, it is not a foolproof, a solution, because the evaluation with which I will demonstrate is kind of restricted right now to Boolean and multi-choice question answering. The evaluation for something like which Dr. David asked about verification, we are still not there with that. But as a community, I hope to see some standardized way of evaluation should come up for verification of plans and all the other different tasks that we are evaluating the language models on. Any questions? Yeah.
That you have when you're evaluating LLM systems is the whole data contamination problem. And I'm wondering with these various kinds of benchmarks, are there protections being put in place so that we would have some guarantees that any performance improvements we see over time are due to algorithmic improvements or model quality improvements versus simply that, in the latest version of training, they've seen those examples.
I don't think there's something, we have a solution for that yet. The reason being, there was something that was initiated by Google, which they said, I think it was called SSID or UID. They started putting a unique hash code in the data sets to indicate that, this data set should not be used for training. But that didn't get picked up. So if you look at, some large language model and give the first half of that hash code, it will auto-complete the remaining hash code. So essentially the data sets that were, built for test-only data sets, they ended up in training. So there is no guarantee as such, and I think this is an open problem. But one other way which, some of the researchers have proposed is to have the benchmark rotate every month or every week, in the sense, like, one thing is that we can keep the test set hidden, but then it becomes an overhead for the owner of the benchmark to evaluate all the language models, which might not be an ideal case. But the other is to just rotate the benchmark so that we can have a new test set every month. In that case, this would there's less chance of having the leakage in the training data set.
We can have like hidden domains, right? Hidden PDL domains. Then we can auto-generate instances of these hidden PDL domains. That for non-visual stuff. But that's also a stop solution. We need something.